Okay, so today we are doing historical data analysis, and on historical data analysis, we can pick up that data from anywhere in web server or maybe a flat file location. So the flow will remain same. We'll adding extra steps or extra approach to read the data, process them, and store in HDFS. Okay, so the idea behind this is batch processing or historical data processing. And what we are going to do is a financial data check. Okay, so this project name we can give as a financial intelligence unit. Financial intelligence unit. All the finance informations we will try to capture. We will see earlier what was the total balance or locations, and if we are changing, how this is reflected in our Hadoop ecosystem. Okay, so here I have created a PPT for that. Let's open that PPT and understand the complete workflow. All right, so first we will check the life cycle. And when we discuss about any life cycle project, then first thing comes is software development life cycle. Okay, what is the life cycle of our project? Software development life cycle. In software development life cycle, there are two popular methods. Many uses waterfall, and some uses agile, which is popular today. So agile methodology is based on Scrum, right? First I will tell you the process, then we will go to the project. We will not be using this waterfall. We will be applying agile methodology where we have stories defined, Scrum call, retrospective stories. So if any task is coming, we define the total time, and fast delivery is there. So this is more on the theory side. Actually, in the agile methodology, you can search what is the agile methodology and how it works. We can say, in when you represent your project like this or any other project, you say your project is based on the agile methodology or working with the software development lifecycle of agile. After this, any project has got this 5 flow, right? First, we develop that in our development environment. So first, in fact, we develop in our local mode, local machine. I'll call that machine as a standalone machine. So all the code, configuration, binary file we create in this standalone machine. And from this standalone machine, we start curling that information. We use curl command, or we can use WinSCP, FileZilla, some FTP software to keep this builded code or jar file into our development environment, dev environment. And this is under your control. You create a different folder, you test them. After testing, you do certain level of testing like regression testing, unit testing. And once your testing is done, then you combine this code in Jenkins. Nowadays we use Jenkins for CI/CD process. Okay, Jenkins is a part of DevOps again. So in short, Jenkins, I can tell you what this Jenkins does. Jenkins is giving you CI/CD features, continuous integration and continuous development. That's what we call integration. You're integrating this information here, this information to the next stage, and continuous development. So that we can do using Jenkins. There are some other platform also. This is the popular one. Then after testing this in dev, we start promoting this to our higher environment, which is SIT, System Integration Testing Environment. After testing this in SIT, we promote this to UAT, User Acceptance Testing. Separate teams are there. This is your part is done here. You're only negotiating with them. Then if they're getting any error, any issues, they're creating incident, assigning to you, you're solving them, telling them back that this is done. Again, they're testing, and it's ecosystem. Continuously the same flow is going on. And after UAT environment, we will promote this to operational acceptance testing. Depends on the firm. Many companies I have seen, they do not perform operational testing. After UAT, they directly promote to production. So this is the part of firm. What is their policy? If it is a critical or high revenue project, then they can follow all these things. Otherwise, if some client is expecting a faster delivery, then maybe after UAT directly we can plan for production deployment. So this is my prod box. And in this prod environment, we will promote it after this level of testing. So this is the flow, complete flow. And after production environment, we test this for some time, which we call a BAU mode. BAU stand for business as usual. Okay, so your team is testing here. They're not commercializing the project. Currently, URL, username, all these things is with you only. Once you are double sure that all features are functional, input they are taking, processing, and time expectation is also okay, then you will announce my project is live with first version 0.1 or 1.2. Once this is live, we immediately surrender or give this to support people who knows Unix and the background knowledge of different intelligence tool. They can, so there are different support level also, L1, L2, L3. I have known since till L3 I think is the highest level. So uh, support team will check if any error is coming in this production box. Okay, with the help of your PDG, and there is one file. Couple of times I have designed the same flow. So PDG is a problematic diagnomatic graph. So what we do, we diagnose the problem which is coming in this production box with the help of this file. It's just a Excel file. Okay, but in this Excel file, this is having complete information about this project. How many jobs we are running, how many schedulers we are running, if one job is failing, so why it is failing, where we should check, which is the directory, all that information is given in this file. So people from L1, whenever any issue is coming, they open the PDG file, they check it. If they are able to understand, they solve immediately and pass one resolution that this is done. This error has been corrected. If they're not able to do this, then obviously the escalation level will start. L2 will start checking. If they can also not do that, then highest level will is L3. They will escalate to L3. L3 will communicate to dev. And if it is a critical issue, now whenever you say error, because this is important when you explain the project, the question can come: what types of error you get in your project development? Okay, and how did you resolve them? Suppose you said this is my problem. Uh, it was giving me problem in the scope side or in the HDFS side, because problem will come from the tool. So one is a technical problem, the one which I'm talking about. So you are the direct uh, single point of contact uh, development. If any code issues or configurations related problem in the file, in environment issues, if we have, then whom we will connect? Administrator, because admin knows end to end about all the utilities and connections, APIs. And otherwise, I can have a data issue also. If I have data issue, then I will directly connect with the business. That you gave me this sample and my whole code is built on that sample, but currently I'm getting different data. So I'm getting this data. This data is unknown to my code. and hence code is not able to understand them and they are breaking in between. So these three are the focal point: first point, second point, 3 points if any issue is coming. That's my project flow. After project, this is the same thing which I have written: development, SIT, UAT, O10, production. Now after this flow, business requirement and use cases. So based on the domain, currently this domain is related to banking because my knowledge is in banking and e-commerce and healthcare. So I'll be giving you just three informations. In banking, there are several use cases which we use based on the historical data. So banking are very old firms and their last 300 years, 350 years data is stored in RDBMS in a different region. And if they want to analyze anything, let's say, I take example of JP Morgan. Okay, so JP Group is upstreaming the data, upstream source, which is a website of JP, right? Upstream source is always a web server, a website of this company or the net banking site, wherever the more number of transactions or accumulation of the transaction is happening. Then from here, they are storing all this data to their downstream source. Downstream source. Anywhere this will be first, whether you work with the real-time data analysis or historical, we will be having this upstream source always. Okay. We from technical side, we do not know this area. We know this area because our communication is with this people. Downstream source means people from DBA team who are handling databases. So database administrator, this team handles all the information, whatever total table is coming, input is coming, column is coming, any corrections they are receiving from the upstream. So DBA team manages them. And at the end of the day, or whenever their business is committed, let's say their time is 2 BST, 2 p.m. BST, Britain Standard Time. Now, once 2 p.m. BST is there, the clock ticks, they will send one alert. It's automation alert, obviously. They're not sending manually. They fix a time after 2 p.m. So let's say 2:00:10. After 10 seconds, we are receiving one alert that our commitment is done. And in mail, our commitment of all the data is done. We have committed information. Now you can start extracting data to your system. Now you are from Hadoop team. So you'll start extracting this data to HDFS, Hadoop distributed file system, a single storage point for Hadoop. This is called a centralized repository, or we call it a collection of data node also. Now, which tool we will be using here? We can use multiple tools. We can use Spark SQL. We can use Scoop also. If my RDBMS is Informatica, I can use Informatica also. I can use Ab initio also. So tools can be multiple. Scoop is internal part of big data ecosystem, and nowadays we rely on Spark SQL also, okay, for extraction. But Spark SQL, as we have seen, it gives one additional feature that directly we can query on this and it can cache that data to Spark SQL RAM. So if you don't want to extract it, then I feel Spark SQL is better. But if you want to extract it, then Scoop can also deal better here if there is any limitations on the RAM side. After extracting this data, then you put so many analysis using Spark and Scala on this data, and you are performing that data modeling stage, which I have highlighted as SK, CDC, and SCD type 2. Okay, so we'll focus on those terms. Surrogate key, what is the CDC and SCD type 2 are the main terms, by the way. Changing data capture and slowly changing dimension. So JP is storing their last 200 years data into this system, downstream source, from 1720 years. Okay, because banks are very old firms. They are having data till 2000. Sorry, this is 1820. And this is 2020 years, the year which we are in currently. This is 200 years data, And all this 200 years data is stored in their RDBMS. I'm not talking about the reason. Reason can be multiple. Some data is in US, some in UK, some in Africa, some in Europe. Now, our job is to extract all data from all the world, all the reason, keep this in HDFS. Later we will talk about what is the cluster size of this HDFS, how many node we are looking for. Okay, this is the idea. Once this data is extracted, so three flow is important here. First flow, suppose you started working on this project today. So you said, I will extract all data, extract last 200 years. This is very easy, because here what I can do, I can pass the table name import, or I'll be creating a script. Okay, I'll show you that when we start the project part. So I'll create a Scala script, and from Scala script I can perform automation. I can call that script. It will pick up the table and directly start writing in HDFS. So that is a data extraction of last 200 years. Suppose this is done after 1 month. So after 1 month, I have extracted all this data into HDFS. It is like complete snapshot we are having, full snapshot of this data to this here present. Question comes for second and third. Second, what if new entry is coming in this? What if new entry is coming in this? So one example, let's see. Suppose you have opened your account in JP Morgan, okay, your transactional or retail account, and this is your data set. So maybe I'll write here. Your data set of transactional account is, what is your customer ID? If you go to bank, you'll have one customer ID. This customer ID is J105723. Then they will have your name, which is say Mike. They will have your city. Okay, so city is North Carolina. Then state, or maybe state is North Carolina actually. City we can write anything. Pin code say 57329. Then what is the total balance? Total balance is in dollar 10,000. Okay. Then when you open this account, what is the opening date? Open date of account. So here we will create open date and closed. Open date of account and closing date of account. So open date is in YYDDMM format. I'm using here 2015. Let's say some account open by 1st January 14 hours GMT. 14 hours GMT. This is the open date, and since account is not yet closed, that's why this will be null. There's no closing date time. This is my one row, guys. Now, in this single row, what we will do? This is result which is stored in downstream source of RDBMS, and I have extracted this data to HDFS. The extraction is done. Now this person says, I am changing my location after 5 years. So in this year 2020, he has shifted from NC to state, some other state, CA. Okay. Now this result, obviously, if person is changing the city, the name will not change. Customer ID will not change, because JP Morgan has another branch in new cities or new state of the US. This is my updated result. Updated result. 105723. Customer ID will remain same. Name is same. State is NC. Pin code is 57329. Sorry, state will change. Okay. Balance of this account is after 5 years. This is dynamically changing. $17,000. Our open date will remain same, 2015 0101 1400. Closing time is null. But this state is changing from NC to CA. Now he will request online or offline or visit a branch, fill a form just like in India we do, right? We fill a form online and we send that to bank receptionist. Bank receptionist will sign off this. Then the bank technical team is running a query how this is updating in system. They must be running a simple RDBMS query from a bank because bank also has a technical people. Select a star from this where customer ID is there, state name is this. This is easily done in RDBMS. There is no critical junctions in RDBMS. In RDBMS, we can directly run a query and store this. Question comes when I want to extract this information and keep in the same table because I don't want to delete my previous data. I don't want to delete this and I want to keep this as well and my new record obviously. I want to keep both and I will set one flag because if I delete this and suppose some malicious activity done in bank and my intelligence team is asking the data, then how can I give this data to them? If I simply run this update query, this data is gone. I don't know 5 years ago where was this person, right? Or maybe this account opening account date I will change here, or maybe I can make one more column that change date or city relocation date, and I will write the city relocation date and date of that when he has relocated. But if I delete this information, it's a problem. That's why I want to keep the history. Now, can you call this has become history? Because from this city to this city, this is 5 years old data. This is the latest data or new result. I want both the information, historical as well as new. But when I check the table, I should know this is the new result and this is the historical data. So this thing will be done by scoop, insert, and update, but not directly. We will perform a data modeling stage, especially the one CDC, changing data capture. In this flow, we will check that in short while. Changing data capture phase will handle your updated result as well as your inserted result. Okay, your updated result and new result, new customer is coming, those things will be maintained by CDC. Then after CDC there is a slowly changing dimension. We'll check that slowly changing dimension after getting the use cases of this banking industry. So we know what last 200 years of data and what we want to do with this data. Now let's see work stream. So first work stream, the topic name we will give as a work stream. Transaction monitoring. Okay, transaction monitoring. So we're every day monitoring the transaction. How many people are transacting 10,000, 50,000, 1 lakh? What is the frequency? And if it is a major transaction, we are keeping a note, and we are checking monthly transaction is how much, yearly transaction is how much. So all the use cases or logic which I will write, it will come under this use case, transactions monitoring. Then second one is anti-money laundering. Anti-money laundering, called AML business. Okay, I think I've written somewhere also here. Anti-money laundering, many cases in across globe, including India. Then anti-bribery and corruption. Anti-bribery and corruption. Right. Then fourth one is fraud data analytics. This is the most talked topic today. Fraud data analytics. Because credit card companies and banking card, debit card and saving card, these two, credit and saving, these two cards are there. And in bank, if you just search it, how many fraud is happening per year in this top banks, okay, 4 to 5 international bank, you will see millions and billions of dollars they're losing just because of fraud. Somebody does a fraud using VPN from other servers sitting in different location, and it's very difficult to catch that person. And that is why they're not focusing on catching the person now, they're focusing on detecting the fraud. So if I am able to detect the fraud, then I can immediately block this. Because if you know the transaction business on any bank, your amount is not transacting or going from one account to second account immediately. It takes some time. So there is a mainframe technology, S400, COBOL, all this three to four things coming, which keeps all this informations in track. So any account takes 30 to 40 minutes for transactions. By the time if I'm able to know this is fraud, I can save the amount, because it's not loss for user. User has lost 10,000, but the problem or the security is losing from the bank side, right? So bank will have to uh, compensate the person. So they're giving in compensation and they're losing 10,000. So this is a huge use case today, and we are applying fraud data analysis on the data science. We try to understand the behavior of fraud. But again, as I said, data science is uh, not a finalist, not a first stage. Data engineer will be the first stage. Always data science team, or suppose you start working in future, you will get the idea that after this data engineering only we are applying or putting this data into science side. So fraud data is very important. I'll put 1 star here. Very, very important topic today. And fifth one, so there are 16 to 17 use cases for banking industry. I'm writing the popular ones. Fraud data analytics, then we'll take one more, cross-border payment. Cross-border payments. If any transaction is happening from, currently we're in India, so let's talk about India. India to cross-border payment. Cross-border means outside country. We are transacting amount that will come under this use case. So from India to the country which they are saying do not transfer any amount without approval, and those countries are as follows. Earlier there was I think the this is no more a red alert countries now. Syria, Somalia, then Sudan. I think NC comes under that, North Korea. So there are sanctions given by UN and US. 16 countries are there, 16 to 18 countries out of 205 countries where you're not supposed to transact 1 rupees also. By mistaken, if you do, your account will immediately come under surveillance. And then we are checking what transaction, how this transaction is happening. These are the use cases. Now, when we have a data, then we will apply on these use cases. Okay, so let's focus on the data now. These are the business requirement in use cases. Next, we'll go and check the flow. So upstream source as a designed, and it is going to Oracle, which is your downstream source. A scoop is there, which is connecting with HDFS, extracting the data. Now, here, I'll start writing the question, which people can ask. Prepare why scoop. So they may ask you why scoop, why not Spark SQL? A very valid question. Okay, then after HDFS, how many table information you're extracting? Okay, we'll stop here and we'll check from this Oracle, what is your daily transaction, as in how many data you're extracting from this to this here. Is it 100 tables a day or 1,000 tables a day? So now we will talk about the demographic of our business. Based on this 5 business, suppose my table, total number of table is 120. Okay, 120 table present in RDBMS. And out of this 120, we have we'll write the delta types. When I say delta types, so this is the delta types. And remember this terms, it helps a lot. Um, Daily table, how many table we are extracting on daily basis. Then how many, when I say daily, it's not 30 days a month. Daily always, so in bracket, I'll write one hint, business days. Business days, okay, Monday to Friday. That's what I'm calling as a daily. So how many daily as in business days we have in a month? 22 days, right? So right here, 22 days. Then monthly, or before monthly, weekly. If I'm working with some data which are which are storing data in early basis, or some table can be early table also. They write data based on early basis. Okay, so here we'll use a concrete info as daily, weekly, and monthly. There's three different data types. Weekly. Weekly means Saturday, Sunday. In bracket, I will write Saturday, Sunday. How many Saturday, Sunday? 8 days, right? Every month. Some month we have 10 all as in 5 weekend also, but frequently we have 8 days. So I'm using the average term here. Then third one is a monthly. Monthly is last day of the month, just like your salary table. Last day of the month, 31st or 30, whichever it is. So one day. Now out of 120 total table, how many table I'm extracting on daily basis? So table on daily basis is into what 22 days, and suppose my daily table is 70 tables. Okay, 70 are daily table. So this information is from table. I will write here table. Then into 120 minus 70, 50 tables are left. 40 tables are for weekly, and just 10 tables are for monthly, which are extracting. Okay, this is their frequency. Now in daily, 70 tables are running. We need to check what is the average volume. What is the average volume of this table? So 70 tables we said for daily. Okay. Now one table is extracting. So I'm keeping average, okay, because I cannot count one by one. It will take time. I'll take an average. Every table is extracting, suppose 3.9 GB of data. This is every table. So 3.9 GB into 70, right, for daily, because that's 3.9 GB data is coming from one table. So 70 table into this is how much? We'll multiply here. 70 into 3.9 GB. So this unit is in GB. Let me use the calculator. 70 into 3.9, 273 GB. 273 GB. That's for daily, and this is of 1 day result, right? This is coming from one single day. This is running to 22 days. So 22 days into this, 22 is giving me 6,006. 6,006 right here. 6. In short, I can say this is 6 terabyte. Okay. Or later, if you confuse, let me write the exact number: 6,006 GB, which I'm tentatively calling as 6 terabyte. So 1 day result is 273 gigabyte. In a month, we have 6 GB result. 6 TB result. Similarly for this, 40 tables in weekly and 8 days they are running. So first we will calculate for 1 day, then we will calculate for 8 days, just like this. So 40 table is equal to weekly, and weekly here I'll take 2.2 GB. Okay, so 2.2 GB, 2.2 into 40, 40 into 2.2 GB, 80 point something. 40 into 2.2, this is 88 gigs. This is 1 day, and 88 gigabytes if I multiply with 8, then 704 gigabyte. 704 gigabytes. Okay, this is not near to 1 terabytes. I'll keep the same. Then 10 tables are a month, and this is only running 1 day. So 10 table, and these are monthly result. And this table is giving me, since this is running monthly, so I take it as 3.5 gigs, and 3.5 into 10 is equal to 35 GB. This is 1 day, and this is only 1 day running, so this will be 35 GB only. This I have assumed. If I increase this number or increase this number, the uh, whole mathematics will change. Okay, so do accordingly. If you think you want to change other number, but this is okay. You can explain the same thing in your project also. This was my total data, but be accurate and double sure about the number. Do not say assumptions. Take the exact number that this was my daily, monthly, and weekly. If they ask this question, let's conclude and add the total number here. So cumulative will be total in a month, and this is cumulative is equal to daily plus weekly plus monthly. Daily result is 6 TB, or let me take GB itself, 6006 GB, because all the unit is in GB. 704 GB plus 35 GB, and we'll add this 6006 plus 704 plus 35. This is 6745 GB. 6745 GB. That's total in a month. Now, if you want to calculate for year, then obviously we'll multiply with this 12, because if you're creating a cluster, you're not creating cluster for 1 month. At least you will do cluster capacity calculation for whole 1 year. Now we need a formula here, and what is that formula? If I'm checking for 12 year, then I'll multiply this with 12 into 12, and this is equal to yearly 12 into 6745, 80,940 gigabyte. 80,940 gigabyte. And if I divide this by 1024, this is roughly 79 terabyte. 79 point something. Okay, so this number is 79 terabyte. This is the actual data coming from business in a year. This is your capacity planning. What we are doing here currently, capacity planning. Now, if this is yearly data, this is the actual data, right? You have not yet replicated this. If you're replicating this, then how many machine is required? If you're replicating this 3 times, then now we need a formula of Hadoop. What is that formula? F is equal to C into, let me change this color. F is equal to, formula is equal to C into R into S. C stands for compression ratio. If you're using any compression ratio in Spark and in Hadoop there are 6 different compression technique. If you remember, there's a gunzip, deflat, bzip2, lzo, lz4, snappy used by default. Okay, so those parts you can revise how many different compression technique is there and which one is the best according to your input file. You cannot say snappy is a by default, so it's always better. It depends on the data. Now when I say data is having 3 categories: structure, unstructured, semi-structure. Now if you're able to know this is semi-structured, then what type of semi-structure? Is it JSON, CSV, TSV, XML? Then if you know this, then you'll ask the business whether it is a text data, audio data, video data, radio frequency data. So many questions comes when you only say data. Data does not justify the whole statement. You have to ask question in question. Then at last you know, okay, this is the unit. Same thing goes for every business. Currently, this is a transactional data. We can consider JSON or CSV. Okay. So C into R into S, compression ratio, R replication factor, and this S is nothing but my 79 terabyte. Sum of total data. This divides by 1 minus I into 120%. 120% we take because of this is the percentage which is trying to accumulate my CPU and my RAM. Because if you say 8 GB of RAM, if you right click on your system and check the total usable memory on disk, so if my system is having 8 GB but only 6.49 GB is applicable, okay, or 7 point something. If you have your machine of 4 GB, 6 GB, you can right click on your properties and you see how many is usable. In bracket you will find here usable. So that's why we are giving extra 20%, because whatever total RAM is there is not given to my RAM. There are some storage 1 GB or 0.5 GB is given for background services. That's the reason this 20%. Okay, so just a justification by Hadoop people, that because if somebody is asking question why 120%, so that's the definition. Now see, if I do not know compression ratio, so I'll use 1, or if I know the compression ratio, then I can put the number, right? For compression ratio there was 2 flag, -1 to -9, and whichever compression ratio you're using, just Google. We need to Google it up. Compression value of snappy, compression value of gunzip, and we'll get the number we'll put here. So I'm using 1 currently. 1 into replication factor is 3 in Hadoop, and sum of this is 79 terabyte. Right here, 79 terabyte. This should be in terabyte. Divide by 1 minus I, and this I is an intermediate factor. We keep this as 1 by 4. As 1 by 4 means 0.25. Can I write this is 0.25? Right. 1 minus 0.25 into 120%. And 120%, if I write in numbers, in values, I is a intermediate factor. So intermediate factor, this is the absolute value. 1 by 4 we give always. Why we are giving I as a 1 by 4, I need to check that. So 1 by 4 is the default value. We always give 1 by 4 only in this calculation. Now 120 divided by 100 is equal to 1.2, right? If I divide this 120 by, because this 0 cancels out, and this is 1.2. So next one, I'll put here the value 1.2. Now I'll take my calculator again to calculate this. 1 into 3 into 79 terabyte. 79 into 3. 79 into 3 is 237 terabyte. 237 terabyte divide by 1 minus 0.25. I'm directly writing the value here, okay, whatever value is coming. So 1 minus 0.25 is 0.75, and 0.75 into 1.2. So 0.75 into 1.2 is 0.9, is 0.9 is equal to 237 divided by 0.9. So 237 divided by 0.9 is equal to 263 terabyte. 263 terabyte. Sorry, Ansika, I didn't get. Which one is the wrong calculation? Okay. 1 second. 1 minus 0.25 is 0.75. 0.75 into 1.2. This is okay. This is good calculation. I mean, this is the numerator and this is the denominator. This whole thing is a denominator. This whole thing is a denominator. This whole thing is a denominator. Okay, if you're thinking A as this part as A, and if you're thinking this is B and this is C, it's not. This is the one unit only. It's not this. Okay, so it's a single unit only. So 237 by 0.9 terabyte. This is 263 terabyte. Okay, this is the actual number. You will have to tell to your business that this is what you're expecting, this much space you need in your Hadoop for at least 1 year of capacity to store and to manage all the data. So storage, we ask them, okay, we need, but why is less than total size? Mm -mm. 79 into 3, that's the same thing. 237 I have multiplied and getting that value. 79 into 3 if you do, so you get 237 only. It's a simple calculation actually. Okay, I'm just multiplying 79 into 3 and this lower side value. Nothing fancy. No problem. So 263 terabyte is the total space. This is the total space which we need for a year. Now you need to calculate the number of node. So cluster size now. Data you calculated, cluster size. This is very easy to calculate as soon as we get this value. 263 terabytes. Suppose my every data node is using 1 terabyte as storage. Now that depends on my cloud vendor who is giving me instances of virtual machine. So they can give me one machine, just like in market. If you go, you can purchase laptop of 1 terabyte storage, 2 terabyte storage based on your budget. Okay, so I'm taking 1 TB as my data node, hard disk space. So one data node, and we'll use here if else, we'll use our pseudocode here. If one data node uh, takes 1 TB as a storage, If one data node takes 1 TB as a storage, then obviously how many data node is required? Then 4. And this is I'm writing, okay? Not necessary that always you'll have to say this. If you want to decrease the number of data node, then you can say I need one machine, one data node in 2 terabyte. But in that case, then your number of CPU and RAM will be less. That's why it's better to keep 1 terabyte is good unit. So one data node takes 1 TB as a storage. Then for 263 terabyte, how many data node? How many data node? So this is like a math question. If one data node 1 TB, then 263 terabyte, 263 data node. Total data node number is equal to 263 terabyte. That's your slave. Total data node, is equal to 263. Okay. Then this is a slave number because data node is a slave. So if I'm having 263 data node, means in the same machine I'm installing task node manager also, because node manager and data node both resides together. We know that. Why? Because if I'm communicating in the same machine, if I'm communicating from one machine to other machine, we know which one is faster in the same machine always. How many master? This is a question. How many master is required? So slave is okay. 263 slave. Then how many master? Master is fixed always. You're not doing any calculation on this or increasing or decreasing. If I'm having 1 TB data, I'll have the same number of master. If I have 100 TB data, I'll have the same number of master. If I have 1000 TB data, then I'll have the same number of master. No changes. Now in this master, since this is production box, that's why I will perform high availability HA concept. And in this HA, we keep multiple name node, because if one name node goes down, then we need second name node. So name node, one is an active name node, and second one is a standby name node. Standby name node. Active name node will be 1. Standby name node will be also 1. If this is not active, this will work. Same thing goes with active resource manager. Active, I'll use short form RM. RM stands for resource manager, which are part of MapReduce and Yarn. This is also 1. And similarly, standby resource manager. Standby resource manager is equal to 1. So 111 each instances. This is total 4, and this is 263. Now, what is the formula for whole cluster? Cluster is a combination of machine, and it's a combination of your slave plus master. Your slave plus master. This is your cluster size. Okay, so master is total 4. Now, if you're thinking why I'm not adding secondary name node, that's optional because I have got 2 name node. I don't need secondary name node. However, if you think if I add one more secondary name node, is there any problem? No problem. You can add it if you think, but I don't need or there's no requirement of secondary name node, because whatever task secondary name node is doing can be easily done by this standby name node. Okay, so 4 plus how many slave? 263, and this is my cluster size 267. I can tell my total cluster size is this much with 4 master and 263 slaves. So cluster design is done. We know what is the total volume of table, what is the total data, what is our individual data types that also we know in daily, weekly, and monthly. And then when we start this actual project or flow, we'll be creating a separate script. So this will have separate script, this will have one script, this will have another script, three different script for tables. So tomorrow when we'll start this part, okay, tomorrow when we'll start this part, we will continue with the number of jobs. So tomorrow we'll discuss some more on the scheduler side, how many different jobs and schedulers we can create. For this scheduler, there are multiple options. Uzi is one of them. In Hadoop, I have used mostly TWS, Tivoli Workstations. It's IBM product. Okay, so you can use both. Uzi, TWS. Many people uses cron jobs. People from Windows. Many uses after TWS cron jobs. Then there is a uh, autosys also, auto system, right? There are multiple tools. Polar, I think Polar also people uses. So scheduler will start tomorrow. How can we create these jobs and how can we create a different schedulers?